you started thinking about, how am I going to solve this engineering problem? We need to create a machine. Tell us about the process. How did you come up with this? We're more interested in that than the features of the robot itself. Does that make sense?
Yeah.
Okay.
Tell us the story of the robot from start to finish.
So we started off at the beginning. We started off at the beginning of the year. We had an idea for our notebook. We decided that to make it more useful to the team, instead of just doing like weekly entries, we would do weekly entries using this form here. We have this one.
And are these throughout your notebook, the form that you're showing me now?
No, we don't have them with us. We usually get rid of them just to save on space. But after we reach a major milestone, we create iterations here. So it'll be just a few weeks stuff put together into one. And then that way we can have it easier to access.
So where's the first sketch of an idea of a robot that you had?
So this is actually from last year, because we kept last year's base.
Okay.
So we decided to keep the base because we realized that speed of maneuverability would be important for Gateway. So we have last year's sketches and prototype. We prototyped it with cardboard because the Hana base is kind of tricky. We wanted to make sure it would work. And so later this year we modified the base. Originally it had 2 encoders on the back and ultrasonic here and the limit switch here. We put encoders on the front 2 wheels and removed the ultrasonic and limit switch. Then, because we just weren't using those, and we knew that to drive sideways accurately, which we needed for our autonomous plans, we would need the encoders on the front.
So if you have sketches, version 2.1, that these are connected dates, right?
Yep, those are the dates.
6, 1, 4. So there's, okay, so is this specific to the drive train?
Yeah, we have
Yes.
sections for drive
Yeah, we
trains
have,
as well.
So this is divided up by the
different.
Yeah, we thought that would make it more
components of the
useful to
robot.
us. We can find the stuff easier that way.
Okay, and were there sketches that are associated with these different dates that are in here?
Not really, there wasn't really that much to sketch for these
Okay.
ones, but later on for like the intakes, we have a lot of sketches,
Yeah.
and we modified those so much.
Did you do the sketches during your meetings, or did somebody do the sketches?
Yeah, during the
We did it
meetings.
during-
You did it like while you were discussing the problem and you
Yeah.
were working together to, okay.
So
Well, that was one of
the robot actually tipped and wouldn't match after that, so we decided we would add this big chunk of metal down here. Robots can sit like this. To hold on our line sensors we wanted to add for our programming skills run, and just to weigh it down more.
And also to hold the batteries in place instead of having them just loosely tied up here.
So, we were having motor trouble the whole time though. We had to add Teflon washers in to reduce friction, but the axles kept coming out. That's actually in here.
We also had overheating problems.
Yeah. So, to stop the motors from overheating, we added these Teflon washers that reduce friction. And the next,
Did somebody type this up just after, right after the meeting? Is that how you did that?
yeah.
So you have some probably handwritten notes somewhere, and you just kind of summarize them on each date. Okay.
And for the next day, these new encoders came out that are built into the motors, and we decided, because the old ones are like these huge red blocks, we just didn't want them anymore. So we got rid of them. And when we were doing that, to stop the wheels from coming off, we just put 4 colors on each wheel and on the axles. Before we just had like the one in there, now we have 4. So that fixed that for us. The colors work, and we actually had upgraded the arm to be faster, so that was causing tipping because it was just going too fast. So we added these metal plates in to weigh it down. And
So that's ballast?
yeah, and then this is our last entry. It's for the reason the motors had actually been losing VEX. The Cortex had been losing VEX net connection, and it would just keep doing whatever it had been doing before. And we didn't find out until after we were done our notebook and came here. Apparently, it was caused by the new encoders. And then once we got here, we found out about that, and they have a firmware fix for it. So just got that fixed.
Mhm.
So they broadcast.
Yeah.
So you obviously kept track of things during the meetings, kept notes and things like that. Do you think that had a positive impact on the?
Yeah, it definitely
Definitely.
helps. I mean,
How so?
seeing the problems that you're faced with and marking them down, like say you go to a meeting and you have a problem and you don't have enough time and you come back, then some people start working on other things and you don't always know what you're actually going to do. And just having that record just helps you kind of help
So
keep
were
your
you all
focus.
just kind of constantly picking up the design notebook and?
Yeah, it's not really done by one person.
It also helps if you had a problem before and you wanted to do better on the robot, like you didn't want it to do that again, you know what you did wrong. So you can just go back on that. Just reminder.
Yep, so here are entries for the arm. Well, what we do is we set up, we used to have a 4-bar linkage last year, and just this year, because of the new 30-inch goals, we needed just that much more extra height, and that gives us that height.
The 6-bar
The
one.
6-bar.
Yes, the 6-bar.
The
And
New
then-
Zealand teams came up with the idea.
Mhm.
They have this sketch from one of their sites.
And we added the rubber bands and the bigger gears to make it go that much faster and keep the strength.
The rubber bands pull the metal together, so
Mhm.
when you lift some, they get closer together, so it's easier for the motor to lift them up.
Are there more rubber bands here than here?
No.
What we did to calibrate these rubber bands is that we learned from a college or high school team that gives little insight. What you do is you take the motors off completely, and then you keep putting rubber bands on equally on all 4 of them until the arm is sitting in the middle of like the lowest and highest. So that way the motors only have to fight either way the same amount. So,
And the motor fights on both sides.
well, like if it's going up, it's pretty easy, and then if it's trying to go down, it has to fight. So
But then it's
it's equally fighting on either side.
What about when there's a load, when there's walls?
that's where the rubber bands come in, because they give it strength going up, and the balls give it more weight to push it back down. So it's fighting them going down, but the weight's bringing it up. We made plenty of sketches with measurements everywhere.
Did you do any calculations about the force and how the weight and all that stuff? Or was it pretty
No.
just iterative
It was more
experimentation?
experimentation. We did the calculations last year when we made the base, just to figure out the right
Yeah.
size for all the sizes.
Just to get the wheels on the right angles and or 45-degree angles to get the program working. Just so it was pretty complicated, but just sitting down and thinking about it.
Did one person mostly do the sketches during the meeting, and did you all sign off on them, or how did you decide? if it was good
I
to
did a
go?
lot of sketches, but I think
Yeah,
maybe
I
a
did
few
some
other-
too.
Were you guys the whole team, 5 people?
Yeah.
Yeah.
5 people. So the first version of the lift was actually not quite like this. We had problems because we couldn't reach the 30-inch goal. Back then, we had the 12-tooth gear and 1 motor powering them. We still had the rubber band assist. So we made some minor changes. By changing the angle of these bars, they used to be straight, and then you can see one of them's off. That actually causes, as the arm raises, it causes it to go like that,
Rotating.
just slightly, giving us a little more height.
Let's figure it out.
One of
Well-
our club is made up of a bunch of teams, and one of our other teams actually thought of that idea, and they demonstrated it with us because they needed that extra height as well.
So we also moved up these mounting points on the sides just a little. So eventually, we realized that the biggest problem was that just the bars were too close together. They used to actually be a few holes closer. So we had to rebuild basically the entire arm so that they would be farther apart. Because like I said, as it rises, they get closer together.
Do you have that sketch in there, where you made a decision about to redo the arm?
Yeah, this is it.
Okay.
This is it.
We're almost out of time, so what's
Yeah.
another real high point, again, in
So-
terms of process?
So
Maybe something you alter
intakes.
like that. Those
Where
were-
intakes, we spent almost like half the year trying to figure out which ones actually work, and only
We started off with all
close to
the
the end.
prototypes, but most of them didn't really work out that well. We ended up coming up with this design, and we built these first. They were sort of medium-sized gears, maybe about this
Just
big,
circle ones.
just circles. And those were having troubles with jamming up and picking up the barrels properly. So we thought it would help if we made them springy, so we had them rotate.
And kind of like, so, say a barrel goes in here, they get pushed out because of the.
But they actually got pushed out too much and would lose their grip. So we ended up making these kind of shredded tanks you see here. They were pretty similar to that.
Why are they interrupted?
Oh, because the way our robot works, it folds up in here to fit in the box, right? And we actually have to turn this just to get it into the box.
Yeah, otherwise the flaps
But
would
it's
stick out.
still, because the element is the way it is, it still works just fine.
Then we went back to the circling tanks for a time, got those working better. And then we ended up realizing the whole year, at the very end, they were too close together.
And you don't even need, you don't need them to come out at all. What we did was we figured out that if you put a barrel here and you line these up with the edge of the barrel, it works just fine.
Cool, we're out of
So,
time.
Yeah.
very good. Thanks, guys.
Thank you very much.
Good luck the next couple
Nice
days.
job.
Thanks.
This has been